Advanced Algebra, Chapter 7, Lesson 3, and we're going to look at multiplying and dividing radicals. Now, you may be thinking, but we've already done that because we have been working with these in the previous lesson, and you are correct. So what we're talking about in this is that we're going to be multiplying and dividing binomial radical expressions. And you remember a binomial is simply an expression that has two terms in it. So a binomial radical would be something that has two terms in it, one of them or both of them being radicals. So maybe something 1 plus the square root of 3 would be a binomial, two-term, and it has a radical expression. So let's look at how to multiply these binomial radical expressions. And really they're going to be in the form of binomials, so we can simply use, and again I don't like the word FOIL, but we're going to use the distributive property. So here's a binomial radical expression times another binomial radical expression. So we're going to distribute the 3, multiplying it by both terms, and we're going to distribute the 2 radical 5, multiplying it by both terms. So in doing that, we multiply the 3 times the 2 and the 3 times the 4 radical 5, and then the 2 times the 2 radical 5, or the 2 radical 5 times the 2, and then 2 radical 5 times the 4 radical 5. Okay, so we multiply those together, we look for like terms, we add like terms, and we end up with 46 plus 16 square root of 5. So nothing really complicated here, nothing different than what we've done before. We simply have two binomials that need to be multiplied together, so we're going to use the distributive property. Now we're going to look at multiplying conjugate expressions here, because this is going to come into play when we talk about division. And you remember conjugate expressions are one where the second term's sign are opposite. So you have the square root of a plus the square root of b. Its conjugate would be the square root of a minus the square root of b. Now the only thing that's different between these two terms is this sign that's in the middle. And this is a very nice situation for us because it allows us to do a couple of things. One, it allows us to multiply this very quickly if we recognize the pattern, and also it's going to be what we use in order to take something that has radicals in it and multiply it together to something that does not have radicals in it. Now you remember when we did the irrational root theorem and we multiplied these zeros together, the conjugates, and you remember that we talked about that every time you multiplied the 0 that contained the conjugates, that radical sign always went away when we were coming up with these polynomial expressions. So whenever we multiply a radical expression by its conjugate, the radicals end up going away and we end up with a real number, or a rational number. So it's very important to remember that, especially when we're dividing, but it also sets up something that allows us to do a shortcut or to multiply very quickly if we recognize the pattern. So in the next couple minutes, that's what I'm going to talk about, this shortcut that we can use when multiplying radical expressions that are conjugates. Right? So what we want to remember is that when we multiply conjugates, radical conjugates, the square root symbols will go away and we will end up with a rational number. So we want to remember that's where we're going to end up. So what we want to be able to do is to quickly recognize conjugates, and then once we recognize their conjugates, to quickly multiply. So the key to this is recognizing the conjugates. So how do we recognize the conjugates? Well, the first terms and the last terms are identical. So both are x here, both are 4s. The sign that's in between them are opposites. So if we have that condition met, it's very quick to multiply these because I can simply multiply the first terms together, or square that first term, x squared, square the second term, 4 squared, and then this sign in the middle will always be negative. So I can quickly multiply conjugates by squaring the first term, squaring the second term, and then putting a minus sign in between, and then I've done that distributive property, but I've done it very quickly. Now conjugates are factored form of the difference of 2 squares, so when I multiply them back together I should get the difference of 2 squares. That's kind of the idea behind the shortcut. So here's the shortcut. If we recognize it, we can multiply very quickly. I notice that the first two terms are the same. The second two terms are the same, and the sign that's in between them are opposites. One is plus or one is minus. So I recognize this as being a situation where I can multiply quickly or use the shortcut. So I simply square the first term, which is 4, square the second term, radical 3 times itself is 3, and put a minus sign in between. 4 minus 3 is 1. So I have my answer very quickly, remembering that, or recognizing that this is a difference of two squares factored. Notice that I have a rational number here. The radical term has gone away, and that's going to happen all the time when we have radicals that are conjugates. Okay, so let's look at a few examples to wrap this up. So I notice in number 19 here, the first terms are the same, the second terms are the same, the signs are opposite, so these are conjugates. So I simply square the 5, 25. Radical 11 times itself is 11. Subtract them, and I have 14. So very quickly I can multiply that, which would give me the same answer if I distributed. All right. Let's look at the next one here. Number 20. So I notice that these are conjugates of each other, so I can square the first term, square the second. Now be careful when you square the second. You have to square the 2, which is 4, and you have to square the radical 3, which is 3, so that's 4 times 3, which is 12. So 16 minus 12 would be 4. So remember, when you're multiplying conjugates, when you're squaring a radical term with a coefficient, you have to square both parts. So I notice that these two are conjugates, so I square the first term, so the 2 squared is 4, and the radical 6 squared is 6. The 8 squared is 64 with a minus sign in between. So 24 minus 64 gives me a negative 40. So I can quickly, again, multiply those, recognizing that they are conjugates. The last one here, very quickly, these are conjugates, so radical 3 squared is 3, radical 5 squared is 5, minus sign in between, so this would be negative 2. So again, recognizing conjugates can make the multiplication of these binomial radical expressions very quick. If they're not conjugates, just simply use the distributive property, and that should be well, fairly simple and fairly easy for you.